So first off, section 6.1 is strictly using properties of exponents, but you've already been exposed to a lot of the properties of exponents. The only thing we need to cover is what happens if you have a negative exponent and really distinguish, wait a second, when do I multiply those powers? When do I add those powers? When do I not change the powers at all? So those are the only minor details we need to fix today. All we're doing right now is just simplifying expressions. Okay, ladies and gents, on page 323, you actually have this information. And it says the following. Product of powers property. When you're multiplying the same base, which, by the way, when I say base, I'm talking about the number you're multiplying each time. Like I'm multiplying A times itself so many times. A times A, whatever M represents. So A is the base. When you have the same base being multiplied by each other, you're going to add those exponents. So if you had x squared times x to the 6th, you would have x to the 2 plus 6, which would be 8, x to the 8th. Well, let's get down an example. You can also do it with numbers. 3 squared times 3 to the 7th would be 3 to the 2 plus 7, otherwise known as 3 to the 9th. Power of a power property is if you have a to the m raised to another power, that's when we're multiplying. So for example, if you have 5 squared raised to the 4th power, that means we have 5 to the 2 times 4 power, which would be 5 to the 8th. A lot of you guys on your pretest did that successfully. Sometimes if we have something inside parentheses being multiplied, raised to a power, that means each item in here is also raised to that power. For example, if you have 2 times 3 raised to the 6th power, that's the same as taking 2 to the 6th power times 3 to the 6th power. One of the most important things that you're going to be dealing with is a lot of quotients from here on. And in second semester, where if you have the same base being divided by each other, we're going to take the numerator exponent and subtract the denominator exponent. For example, let's say you had 3 to the 7th power divided by 3 to the 5th power. That's the same as taking 3 to the 7 minus 5, which is 3 squared. If you have a fraction or a quotient being raised to a power, that means you can take the numerator to that power and the denominator to that power. For example, if you had 4/5 raised to the 3rd power, that means you could take 4 cubed divided by 5 cubed. So some random thoughts that we definitely need to be putting down. A to the 0 power is 1. That's something we forget. Something we forget because it's so simple. But we need to realize that anything to a 0 power will be represented as a 1. For example, no matter how big the number is, if it's to the 0 power, it's going to be 1. Another thing is if we have a negative exponent. A to the negative n is the reciprocal of a to the n. Like this property that we used here, a to the n. A to a negative n is the reciprocal of a to the n. That means we're dealing with the denominator. For example, if you have a to the negative n, we can represent that as 1 over a to the positive n. It also works the other way. Let's say I have 1 over a to the, well, and we can even do 3 to the negative 2. This negative exponent means I need a reciprocal of this. Wait a second. Reciprocal of this would look like 3 to the positive 2 over 1, otherwise known as 9. So be aware, if you have a negative exponent, that means it needs to move. If it's in a numerator, it needs to move to a denominator. If the negative exponent's in the denominator, that means it needs to be moved to a numerator to become positive. We always want positive exponents. That's always the goal. First example, if we're evaluating this expression, 2 to the third power raised to the second power, I've got an expression raised to a power. So I actually multiply those powers. This is going to be the same as 2 to the 6th, or 2 to the 3 times 2, which is 2 to the 6, otherwise known as 64. If you had 8 cubed times 8, well, wait a second. This is like 8 to a first power. 8 to a first power. I could represent that as 8 to the power of 3 plus 1, which turns into 8 to the fourth power, which then becomes 4096. Let's say you had 3 squared to the fourth power. See if you can do this, and then look up at the screen to see if you got my answer. So when we had a fraction raised to a power, we can take each one of those pieces, raising it to that power. But notice how this fraction is raised to a negative exponent. This is where we have to be a little bit careful. I can take each one of these pieces, the 1 and the 5, and both raise them to the negative second power. But notice, I also switch them. I do the reciprocal because of that negative sign. That negative exponent switches the fraction, making us get just a 25. So switching gears to algebraic expressions, now we're dealing with products within parentheses, or quotients within parentheses. We're going to take each thing inside parentheses to the 5th power, and when we have x to the 2nd power to the 5th power, we multiply those powers, giving us 32x to the 10th. That was on your pretest. Next example. So let's say we chose to move y to the negative 2nd power as a reciprocal, moving it down. And then notice, wait a second, you have y to the 2nd power times y to the 3rd power. This helps us see that 1 over y to the 5th also. Let's say we had the following situation, 3 to the 3rd times 3 to the negative 5th. We have the same base and being multiplied, so I'm going to add those exponents. I add them together, but 3 plus negative 5 is the same as 3 minus 5, giving us a 3 to the negative 2nd, but wait a second, I've got a negative power, and that's going to make me do a reciprocal, 1 over 3 squared, which is 9. Dealing with this, I've got a couple options. I could either take x squared, raise it to the negative 3rd power, y to the 4th, raise it to the negative 3rd power, and then deal with the reciprocal, or deal with the reciprocal now. Taking 2 times negative 3 and 4 times negative 3, and then taking the reciprocal of both of those. I go over one of them. First off, I notice x to the 4th minus x to the 1st, or sorry, if you took x to the 4th minus the 1 down here, you get x cubed. If you took y to the 10th minus the 3 down here, you get y to the 7th. So our answer turns out to be x cubed y to the 7th. This, on your pretest, was the most successful. Most of you already know what you're doing. We just got to correct your thinking. Like if I'm subtracting 2 polynomials, I need to distribute that negative. So let's go through this. First off, I just want you to be aware that when we add or subtract polynomials, depending on what textbook you get, sometimes they might write it vertically or horizontally. Just so you know, I'm going to go with the horizontal today. I just wanted you to be aware of the vertical. If you see it vertically, it becomes, you just add like terms, like what you see. But I'm going to concentrate more on the horizontal form. And on the pretest, I noticed a lot of us missed this because we didn't distribute that negative sign. So those signs all change, and then I get like terms together. So 2x squared and negative 3x squared. is negative 1x squared. When we're getting like terms together, the term or the x squared does not change. We don't mess with the exponents here when you're adding like terms or subtracting like terms. We've got two x's and then a positive 4. So just be aware, when you subtract polynomials, that was the biggest mistake, is not distributing that negative sign. So if you saw it in vertical form, it's kind of like multiplying 2-digit numbers, where you take the negative 3 and distribute it throughout. So negative 3, you know what I'm saying, right? Becomes negative 12, negative 6x, positive 3x squared. And then you have a placeholder. Distribute the x to everything. So you get positive 4x, positive 2x squared, and negative x cubed. It's kind of nice lining up the like terms. So if you ever see it in vertical form, that's how we would attack it. Now what we're going to do is more horizontal form. So when I take x and multiply it throughout, I get the following terms. But then I've got to take the negative 3 and multiply it throughout. So some of these we could do quickly from using our knowledge, or using, well, some in addition. Wait a second. Something times its conjugate is always going to be the first squared minus the last thing squared. First term squared turns into 16n squared minus 25. So when you have a binomial squared, you can take the first one, square it, minus twice the product of those two terms. And then add on the square of the last term. That's what those formulas mean in your book. So here's the challenge with the last one. In your book, if you've got something cubed, there's a special formula. So the formula says you take your first term and you cube it. And then you have your middle term. Your middle term is supposed to be plus 3 times the product of your first term and your second term. Wait a second. Plus your second term squared. No. Your first term is supposed to be squared. And then you have plus 3 times your first term, and then times your second term squared. Plus your last term cubed. Let's recall what that formula was from previous screen. We had, if you have a plus b cubed, that turns into, one of the formulas on the ACT sheet looks like this. It's a sum of cubes. So it turns into the following piece. And I'm going through, wait a second, let's back up. This spot means your first term. This spot means your last term. So this is why I took my first term and cubed it, because that's what this formula said to do. And then I added 3 times the first term squared times the second term. Notice how our first term was AB squared times our second term. Plus 3 times the first term times the second term squared. Plus the second term squared. We're starting to realize it's all about interpretation of these formulas. Interpretation of function notation. Interpretation of everything. When you're given this formula, if you see it on a formula sheet, you've got to recognize it as, wait a second, whatever's in the first spot, I'm going to make sure I cube it here, square it here, just multiply it here. Whatever's in the second spot, I'm going to make sure I put it in this spot. Put it in this spot and square it. Put it in this spot and cube it. That's how we would interpret that. I just wanted to expose that to you. I realized it was overwhelming. Your homework actually does not have this on it, but you needed to be exposed to it. Don't dismiss it. Check out your schedule for today's homework for 6.1 and 6.3.